I am SB sir, and today I will be teaching you the basics of lung expansion. And lung expansion means the lung expands with a pressure change that we know. And for this I have drawn this curve. This curve is from Ganong, and I will explain you this curve and the differences between the lung compliances that we see in various lungs while people have different respiratory diseases. So I will now go to the explanations of those things. Let us quickly revise whatever we have was taught in the earlier classes. So last time what I told you, that there is the lung expands because the chest wall has an inherent property. The chest wall has an inherent property of expansion, so it will always stay expanded relative to the lungs. Relative to the lungs, the chest wall has always an expanding property, and it will always try to pull up the lung. So if this is the pressure volume curve of the chest wall, and this is always the pressure volume. This is the pressure volume curve of the lung. Why is it why this curve that I have drawn here is to the right of why the lung curve is to the right of the chest wall? That I will explain first. This is the lung curve and this is the chest wall. So for this explanation you need to know some certain things, and those things are: this is the zero pressure line, that is the atmospheric pressure line, the zero pressure line. This is the zero pressure line, and this is the positive pressure part, and this is the negative pressure part. So the lung, so we see that lung always expands in a positive pressure. It starts its expansion from the zero pressure line. It starts its expansion in a positive, in the positive part of the pressure line. So this is the lung expansion. Lung expansion, here we have plotted the vital capacity or the increase in volume of the lung. So this is 100% of vital capacity, means 6 liters of air is taken in, and this is 25%, say 1 liter. The total vital capacity is not 6 liters. 6 liters is the total lung capacity. So I will rub this out. This is 5 liters. It is a vital capacity. This is 25% of vital capacity. Vital capacity as a percentage is written here. So this is 25% of vital capacity. So this is 0 to 25%. So this is 50%. This is 75%, and this is 100%. Say this is 1.25 liters. 1.25 liters of a lung expansion. This is 2.5 liters of lung expansion. This is another 1.25, means 3.75 of lung expansion, and this is the 5 liters of lung expansion. The total lung expands in this y-axis. The lung expansion is drawn in the y-axis, and the pressure under which the lung expands, the chest wall expands, are in the x-axis. Now we see that the pressure, this is the lung, means here the lung means the lung isolated. It is an isolated lung. Isolated lung means it is not present inside our body. Rather, we have dissected out the lung from our body, and we see the expansion of the lung. The lung is independent now. It is just here this type of expansion for the lung is for the lung tissues only. How the lung tissues expand. This is not in our body. This lung is not inside our body. And this chest wall is also, say the chest wall is also, while we draw this curve of the chest wall, this chest wall is also the inherent elastic properties of the chest wall. The chest wall is independent from our body. So the chest wall is always, see the expansion of the chest wall, this is the full expansion of the chest wall, and it is where the lung volume is so low. So from this curve it is apparent that basically the chest wall is trying to pull up the lung. It is trying to pull up the lung. It is trying to pull up the lung up to a certain extent, and this is this part of the curve. This curve, this is that of the total respiratory system. The total respiratory system means it's inside our body. The body the lung and as well as the chest wall in our body, as humans respire. So this is the total lung capacity, here also the total lung capacity and the highest volume. So we see that these three pressure volume curves, the relationship between pressure volume curves of chest wall, the relationship of pressure volume curve of lung, and the relationship of the pressure volume curve of our whole respiratory system, these three curves are different. So there are differences in expansion in these three tissues while the chest wall, the tissues of the chest wall will expand at a much lower pressure to its highest volume of 6 liters. At a much lower pressure, it starts its expansion at say -40. At -40, the chest wall starts its expansion and it completes its expansion at somewhat just above the zero pressure line, just above the little deflection of the zero pressure line, and it completely expands here. While we see that of the lung, it doesn't expand. The lung tissues doesn't expand at all in the negative pressure zone. It starts to expand at the positive pressure zone. The lung expands at the positive pressure and it continuously expands and it reaches the 6 liter volume mark. Then we can, from these two curves, and in our body, the chest wall as well as the lung is present in our body, and actually the lung is adhered. Completely adhered to the chest wall because due to the negative pressure zone in the intrapleural space. So the chest wall expansion forces the lung to get expanded. The chest wall, the inherent property of the chest wall expansions, it forces the lung to get expanded, and we get this and this curve of the pressure volume curve of the total respiratory system, or the pressure volume curve as present inside our body. The thoracic cage with the lung expands expands like this within this change of pressure. Within this change of pressure is around -40 to +40 zone. This is the zone where the total expansion takes place. This pressure zone here, this pressure zone is required for the chest wall along with the lung to expand. So actually, from this curve we do note that this line falls in between the chest wall as well as between the chest wall and between the lung. So that means that chest wall is trying to pull up the lung, and it is this line that is in between these two lines that our body expands its volume. And this is the compliance curve. This is called the compliance curve of the lung. So what is compliance? We know that compliance is the ability of the lung. Compliance is the ability of the lung to expand. Compliance, C-O-M-P-L-I-A-N-C-E. Compliance is the ability of the lung to expand, means increase its volume by a change in pressure. So if there is a change in pressure, if there is an increase in, if there is a lowering of pressure or an increase in pressure, if there is it can be lowering or an increase in pressure, the change in volume that occurs is called the lung compliance. So the compliance curve of the lung is this. The compliance curve of the chest as well as the lung in our total body, human body, is this, and the compliance of the chest wall is this. So these are the three different compliances. The change in volume per unit change in pressure is the definition of compliance, and these are the three different curves of the independent lung, independent chest wall, and the compliance curve of the human body, of our respiratory system. Now we want to go into a little bit detail about this pressure volume relationship. So this is pressure and this is volume. That just now I told you, this is the change in volume and the change in pressure. So any area within this curve, any area within this particular two defined axis will be of that of pressure into volume, pressure multiplied by volume, any area of this curve. So this will actually resemble some work of breathing. It will resemble pressure into volume becomes work. How pressure into volume becomes work? Why pressure into volume becomes work? Pressure multiplied by volume becomes work. I will explain this phenomenon, why in the pressure volume curve any area that is there in the pressure volume work represents the area of work done by the lung. Why it is the work done by the lung can be calculated from the pressure volume curves, from the pressure volume area. I will explain that, because any area here is actually multiplication of pressure into volume. We know what is pressure. Pressure is force per unit area. And what is volume? Volume is centimeter cube and area is centimeter square. So centimeter square and centimeter cube goes away, and centimeter here one unit, one dimension is there. So force into distance is a unit of work, force into distance. So any area in this pressure volume relationship represents the work done by the lung, and work done by either the lung or the chest wall, work done by the chest wall or that of the total respiratory system, So any area in this curve represents the work done by these three different volumes. The chest wall will expand and contract in a separate way when it is independent. The lung will expand and contract in this change in volume with this change in pressure. The chest wall expands and contracts with this change in pressure, while the total respiratory system changes. The pressure change required for the total respiratory system in our body is this amount of area, is this from here to here. So it is plus 40 to minus 40. So this is actually the pressure volume relationship of the total chest wall. This line, this is of the chest wall, which expands at a much lower pressure. And it just in the zero pressure line, just right to the zero pressure line, it assumes its full volume, and this is of the lung, which only expands like a balloon with a positive pressure. While we inflate a balloon, it inflates at positive pressure. So it only inflates at positive pressure, and it assumes 6 liters at around 20 centimeters of water. At around 20 centimeters of water, lung will expand to its full volume. The chest wall at much lower pressure, say at plus 5, and the total respiratory system is this. It will require this range of pressure to fully expand at 6 liters.